Greetings and welcome. Taking a look at parabolas on page 659, last night's homework, question number 15. And the directions ask us to, for the equation of the parabola, find the coordinates of the vertex, focus, equations of the directrix, and axis of symmetry, and then graph the equation. So this appears to be a parabola in horizontal kind of standard form here. I suspect that because the y term is the 1 squared, and horizontal standard form for the equation of a parabola is the following. So I can more explicitly write it in that form if I want, although you don't have to, but you could write this x minus 0 if you'd like. So gathering information from this, we're able to determine that the vertex is at 0, 6. We know that it is a horizontally oriented parabola. Horizontal. We know that this value here, we know that 4p is equal to the number, the coefficient in front of our linear binomial. So if 4p equals 4, I could solve for p, and I'll get p is equal to 1. So the fact that it's positive tells me that it opens to the right, or towards the positive direction on that axis. So that's right in the case of the x-axis. P is also the distance from the vertex to the focus, as well as the distance from the vertex to the directrix. So if I now want to find out where the focus is, I'm going to add this p-value to my x coordinate of the vertex. So 0 plus 1, 6, which that ends up equaling 1, 6 clearly. For the axis of symmetry, that's going to be a horizontal equation in this case. That's going to be in line with the orientation of the parabola. So that would be x equals a number, and the number that will equal is the x coordinate of the vertex. And the directrix is going to be a vertical line. It's perpendicular to the axis of symmetry, so it's y equals a number. And it will be p units away from the vertex in the opposite direction. So it'll be 0 minus 1, or y equals -1. And I just want to point out that this is an equation. It's not a number that I'm looking for. Y equals -1 is a vertical line. X equals 0 is a horizontal line. So in order to graph this, let me just pull up this grid here. I think this one will suffice for us. Let's see, actually. Let's see, hide those. Where is our vertex? 0, 6. So yeah, I'll want to, and it's opening to the right. So center it somewhere around there, like so. And let's plot some points. So our vertex is at 0, 6. So there we are. The focus is 1 unit to the right of that. The directrix is 1 unit to the left of that. So those are where those would be. The axis of symmetry passes through it and would be horizontal in this case. And then to find 2 other points on this, I like to do kind of this little squares method where I find the distance from the directrix to the focus, which is 2 units there, and then I go perpendicular in both directions, that amount. And that gives me 3 points, and I used to require students to have at least 5 points for a parabola, but you guys are familiar enough with the shape that you guys can base it off of those for now. So that would be what our sketch looks like for problem, what was this, 15? Yeah, sounds good. So let's take a look at one more problem from last night's homework, and that is problem 27. And let's see what clues we can gather. It says the parabola passes through the points 5, 2, has a vertical axis, so vertical means it's going to be x minus h squared equals 4p times y minus k, and has a maximum at 4, 3. So what we know is that the vertex is 4, 3. I know that a particular xy, so x comma y, is equal to 5, 2. I don't know the value of p yet. I know that it's vertical, so I picked this version of the standard form. And I'm going to now plug in what I know, solve for what I don't. So this is why I wanted to do this problem. So let's plug in 5 for x. Actually, let me label these just to be awesome. So that'll be my x, and this will be my y, this will be h, this will be k, and I'm trying to solve for the p. So I'll have 5 minus 4 squared equals 4p, that's my unknown, y is 2 minus 3. There we go. So let's solve this equation. We'll simplify a little bit first, so that's 1 squared equals 4p times negative 1. 1 squared is 1, so that's negative 4p, and divide both sides by negative 4, and I will get that p equals negative 1/4. So there's the value of p, and that tells us that, well, first of all, we knew it was vertical. The fact that this is negative means that it would open towards the negative axis, negative vertical axis, right? So that's going to be opening down. We can find our foci, or focus, sorry, there's only a singular one of them. So the focus is going to be the vertex, and I'm going to add this negative number, all right, to the y-coordinate because it's vertical. So that's 4, 3 plus a negative 1/4. And I guess I could write that as 4, 2.75. If we wanted, we could write that as find the common denominator there if we want. So that's 12/4 minus 1/4, so that's 11/4 if you want it that way. But since this is an ordered pair, this is actually one of the rare occasions that I'd let you write it as decimal or as a mixed number. So 2 3/4 if you wanted that as well. So for the directrix, I guess I started with axis symmetry earlier, but that's fine. So since this is vertically oriented, the directrix is perpendicular to that. So this is a horizontal directrix, so that should be y equals some number. And the number it will equal is the, let's see, here we are. It will be the vertex, and I'm going to subtract the p value from the y-coordinate this time because it's vertical, so that's why I'm choosing the y. So 3 minus negative 1/4. I'm going to get y equals 3 plus 1/4, or 12/4 plus 1/4, so 13/4. Or I could write that as y equals, what's that going to be, 3.25. And the axis of symmetry is going to be in line with the verticality of this, so x equals a number, and it will be x equals the x-coordinate of the vertex, so x equals 4. So let's actually write this in standard form. I know I had the equation of standard form written down there, but let's plug in what we got, where I'll plug in hk and p here. So I will have x minus 4 squared equals, let's see, 4 times a negative 1/4 is negative 1 times y minus 3. So that's actual standard form. And let's see, did they want us to graph it? Sure, they did. So let's do that. Let's so let's see, this is at over 4 up 3, and it opens down. So something like that should do. So I'll paste, and let's see, let's plot some points. So the vertex is over 4 up 3. And this is actually going to be very small scale by the looks of things. The focus is 0.25 underneath that, and the directrix is 0.25 above it, so at 3.25. Let's see, so pretend that that's like that. And let's see, so let's use the little squares method. So it's 0.25, 0.25, so that's 0.5 between the directrix and the focus. So over 0.5, perpendicular to that, I get a little square right there. And over 0.5 this way as well. So my parabola is going to be something like this. And it's also, of course, is symmetric over the axis of symmetry, something like that. Whoa! So there's problem, what was that? What did I say? 27. So thanks for watching, friends. Hopefully that all made sense. We're going to do some more practice with parabolas in today's lesson. Bye-bye.